Our example number 2 is here, and it is saying that a cartoon of mass 0.4 kilogram is thrown across a table with a velocity of 2 meters per second. The resistance of the table to its motion is 50 newton. How far will it move? So that means that if I have this as my table, I can draw anything like this to show my cartoon in this direction with a velocity of 0.4 with a velocity of 25. The velocity that was projected with is equaling to 25 meters per second. It has a weight, but these are not so relevant forces. So the resistance here to the motion, and that would be maybe say frictional resistance, is equivalent to any newton. It was just thrown, and you know that when you push something and it moves, it will move because you have given it an initial velocity. But as it's moving, you're not going to be following it, pushing it. That means that there is no driving force. There is no force that remains on it to make it continue moving, but it is only going to move because of the initial velocity you've given it. So I can say, using Fr equaling to ma, where Fr is force in the direction of motion minus force opposing it motion, and we say there is no force in the direction of motion because you will push it and leave it. That means that there is no force that will continue making it continue move. So it will be 0 minus the one opposing is 50, isn't it? 50 newtons should be equaling to ma, which is 0.4 a. Is that right? And now my acceleration in this case here will be 40 divided by that. You can get your calculator there, and then I can say a is negative 50 divided by 0.4. So and that is equivalent to 125. That is 125 meters per second. It is a negative, implying that when you push it, the body will finally come to rest. Therefore, in that process, it will be decelerating. But our interest is to find out how far will it travel before coming to rest. And now we can say from v squared equal to u squared plus 2as. If it comes to rest, that means that the final speed will be 0. So therefore, I will say 0 is equal to the initial speed was 25 squared plus 2 into acceleration is negative 125 times s, isn't it? That means that this can now be 250, isn't it? Times 2. So that means my 250 s equaling to 25 squared. Therefore, divide by 250 divided by 250. My s is equaling to 2.5 meters. So that means that therefore the body travels 2.5 meters before coming to what? To rest. Is that fine? And then they are saying that what must be the resistance if it travels only 2 meters, isn't it? So what should now be the resistance to its traveling 2 meters? So from also, we can still use v squared equaling to u squared plus 2as. So still, if it travels 2 meters, but at the end will come to rest, that means that the final velocity is still 0, equaling to the initial velocity, okay, plus 2a times now 2 meters. So that means that my acceleration is going to be equaling to negative 25 squared divided by 4. What is my acceleration in that case? So that means 25 squared divided by 4. This is before a. I think we're getting that. So divide by 4. That is 156. Please make sure you follow this part. Well, let me write it like this is minus 4a equal to 25 squared. Divide by minus 4, and then my acceleration is negative 156.25 meters per. So that means that in that due course, it will decelerate at a rate of that. But now again, what they want from us is what must be the resistance, isn't it? So I will say I'm going to use Fr equal to MA. So Fr will be the force in the direction of motion. We said there is no driving force in this kind of problem here, because when you push a body, you give it initial velocity and then it moves on its own. So 0 minus the resistance still is what now we need. The new resistance that we need should be equal to MA, which is 0.4 times our A is negative 156. Let me get some bigger space here, then say 0 minus R1 equaling to MA, which is 0.4 times negative 156.25. And then that means negative and negative may go. And then my R1 will be this times that. The negative will. If you want, I can first leave it there times 0.4. That is 62.5 negative. So that means R1 equaling to 62.5. And then we say, therefore, the new resistance in 2 meters is now 62.5 Newton. So this would basically be our resistance to the motion for a distance of 2 meters. So let's meet in the next example.